It's time to sort with the Java class libraries. So today's goal, we're going to use this fancy schmancy thing called arrays and collections. And it's going to allow us to, yes, you guessed it, sort. Okay, it's going to allow us to sort primitive types and objects. And it's cool when you think about how do you sort objects? Like how do you compare, like how do you sort apples? Are you going to sort them by how green they are, how red they are, how big they are, how tasty they are? Well, you need to know how to compare them. So we're going to learn how to sort objects using something called comparable. And this is using interfaces for which we have not covered, and interfaces is definitely not on the AP exam, at least not in the year 2020. And so this might fly over your head a little bit, but that's okay. We're going to show you the things. Things are going to be magical. You're going to be happy with it. So let's look at the Java class libraries. If you look in the arrays class, there's this binary search. Wait a minute. Why didn't you tell me binary search was implemented by arrays? You were telling us that we needed to implement it. No, I didn't tell you you needed to implement it. I just told you how to implement it. Okay, but there's a binary search method inside of the arrays class. Okay, it's a static method inside of the arrays class, and it'll do exactly what we were talking about. And before you can do binary search, you need to sort it, so you can use the arrays class to do it. Then we have something called collections, which can do binary search and sort for us, as well as this handy dandy shuffle thing. Collections will work with collection classes, for which array lists, okay, is something that we've learned in the previous section unit, and that will allow you to sort array lists. So what are the differences between the methods in arrays versus collections? Right here, what's the answer? What's the answer? I just told you arrays is going to work with arrays, and collections work with collections, duh, such as ArrayList, okay? So how can we sort? Let me count the ways. This is a little bit of repeat, right? Arrays sort, collections sort is what we're going to need to do to sort stuff. Now, when we sort integers, it's pretty obvious how we sort them. Okay, primitive types have well-known comparisons, but objects, how do you sort them? So they need to implement this comparable interface, or if you're super cool, you can send in a comparator. That's basically saying, hey, object, I know you don't know how to sort yourself. You don't know how to compare yourself to one another, but I do, and so I'm going to tell you how to do it. All right? So we're going to look through some of that today. Let's look at primitive types. We know about arrays, primitive types. We're going to stick with integers. Okay, very simple. You create an array of integers. You say Arrays.sort. Boom! They're sorted. Okay, simple. Now, let's look at strings. Strings is not a primitive type, but that's okay. You can still sort them. And strings already come with the comparable interface already implemented for you. And it'll sort just like you think. Words in a dictionary, okay? Cases do, I wonder if cases matter. We'd have to test that out. Very good question. You're so inquisitive. So apple, carrot, duck, elephant, bunny. Some of these are not like the other. We can sort them. Same way we did before. You just take this, put it in there, and they will be sorted, okay? Oh, we get to watch a video. How much fun is that? Strings, they implement the comparable interface, okay? Now, if I wanted to use collections, the first thing I need to do is to create a collection. Well, I'm going to get a list, okay? This isn't, we haven't covered interfaces. This is so tough. List is very close to an array list, but it's an interface of an array list. And how do I get an array list or a list out of an array? Well, I say, hey, arrays class, will you make a list for me? And it says, why, yes, I'll make a list for you. Here it is. And you go, thank you. I'll take that as a list. Thank you very much. And then I can put it in the collections class and sort my list. Very cool, right? And so are these the same? Are ArraySort and CollectionSort the same?
Yes, exactly. That's what I always say. It's like, God, you get me.
Well, you're an easy guy to get.
I can't go home. He's probably waiting for me. I mean, he's going to be my boss. He's the younger brother.
How old is he?
42.
Same! My younger brother's 42 also.
Same!
I mean 32.
32.
32.
32. Same.
Same?
I was thinking the
That's
same.
so weird.
Mine's
You thought 32 and then you said 32.
32.
That's same. Crazy. Do you want a glass of wine?
I love wine.
Red wine?
I love red wine.
It's like two same.
That's insane.
It turns
Totally
out the guys had tons in common.
That's so weird.
Like Dick,
The last time
I went scuba diving. Wow. Eating. Captain Crunch. Same.
Okay, so I guess we could see that Arrays.sort and Collections.sort are, essentially the same. So how do we implement this? Well, when we want to compare objects to one another, we have to ask if one is greater than the other. And so we're going to return a negative value if one object is less than the other. And we're going to return 0 if the objects are equal, and we're going to return a positive value when one object is greater than the other. So if we had this method CompareTo and we used A and B, then we say if A is less than B, return -1. Awesome. Do you like this implementation? It's okay. It's 3 lines. Could be more if I were to actually put braces in there and everything like that. So here is a better implementation. When I compare A to B, all I need to do is subtract B from A and I get the same values up here. Very cool, right? Very cool. So for example, if B were 0 and A were 1, then I have a positive value. If B was 0 and A were 1, I return a positive value. Awesome. If B is 2 and A was 0, I'd return a negative value. I would return -2, which is just fine. Okay, I don't have to always return -1. I can return -2. Very cool. So this is how to use like a static method to compare two different objects, or in this case primitive types, by just simply subtracting one from the other. But it doesn't always work. Let's say I have my class. I have an object called my class. I want to compare one to the other, okay? Let's say that I were to compare them like this. Well, that doesn't quite work out, right? That doesn't make any sense. So what I'm going to do is let's show more details of my class. I'm going to have my class implement the comparable interface. It's going to implement compare. Now notice there's no static here, and it returns an integer, and it's going to take the class, but only one object comes in to the method. Okay, I'm going to compare myself, this object, to the object that was passed in. And so the way to implement this type of method using classes and objects is to have the class implement the comparable interface and just follow the syntax here, put brackets and the my class in there, okay? And then when you do CompareTo, you'll put my class, which is my class here, and you'll say this and whatever values you're going to use. In this case, I'm still using integer values, so I just subtract B from myself, and that will return basically what I'm looking for. Very cool, right? So let's look a little closer at this. Let's say that in my class I have a double value. Okay, it doesn't declare or doesn't have an integer value in here. I want to sort by this double value. It could be 0.1, 0.2, it could be 50, it could be 0, it could be anything I want that's a double value. My CompareTo method returns an integer. Okay, it still takes a my class object. So how do I want to do this? Well, I want to say if this dot value is less than b, return -1. If this dot value is greater than b, return 1. Otherwise, return 0. That totally works, and I could do that. But let's look at the faster way. Can I do this? Can I do this dot value minus b dot value? I work with integers. Does it work? Oh, wait. Oh, wait a minute. Well, these values are doubles, so when I subtract them, they're not an int. Well, that's an easy fix, right? I just cast to an int, right? Just totally cast it to an int, and then it will work, right? But wait. Bug. Let's say that this value is equal to 0.5 and b value is equal to 0. So if I'm going to take 0.5 and subtract 0, I'll get 0.5. What will I get when I cast that to an integer? I'll get 0. Exactly 0, which would then lead the sorting algorithm who called this method CompareTo to believe that 0.05 and 0.0 are the same. But they're not the same, all right? They are not the same. So we would want to go back to doing our ifs, right? Well, you know what? Fortunately, Java provides us yet with another helper class method, okay? SignNum, or SignNum. Well, it's this, SIGNUM, off of the math class. And what it's designed to do is to handle cases exactly like this for us, okay? If this value, which is a double value, is less than 0, if it's negative, then it'll return -1. If it's equal to 0, it'll return 0. And if it's greater than 0, like 0.1, then it'll return a positive value. And it'll be an integer value. So that's exactly what we want. How cool is that? I love those Java class libraries. So we haven't really talked too much about the interface comparable E. All right. This is how it would be declared. You do not need to be able to do this in any exam, but it is handy to know what's going on underneath the covers. So basically what happens is that we declare an interface that is very much like a class. You can think of it as almost exactly like a class, but it would be exactly like an abstract class. We haven't covered that either. Never mind, I'm confusing you. But if we declared an interface, it would have this method just like this, and so one would implement it like this. Okay, so you would take this E here is a generic type, just like we do inside of ArrayList, and so you could put anything in here. If we want to do integers, we'd have to use the capital I integer, the wrapper class, in order to handle it, because the CompareTo needs to have objects inside of them. So this is one way we could do it. All right, very cool. And we know that many objects that are given to us already implement this. And if we have an object of our own class, we can go ahead and implement comparable. That way we can sort them. You know what? You need to practice this. Even though this was a spectacular lesson, you're not going to get it rock solid in your brain, understood, until you practice it. All right, so let's go to your next video. There we have some exercises, and we'll practice it there.